EDU-ARCTIC 2, Polar Research for Education, innovative program in Poland and Norway. Webinars.
The title again is Caves and Humans. It's a webinar in the EDU-ARCTIC 2 series, an English version of the earlier Polish language webinar delivered by Jerzy Girzejewski. And let me start with a short introduction about what the caves are and what would people even have to do with caves. So, according to definition, caves are naturally formed voids in rocks of such size that a person can enter them, crawl or squeeze in, or run or climb if the cave is big enough for people to stand upright. Sometimes it's very dark, so it's often a challenge. And for humans, the caves have always been and still are a world of mysterious corridors, of wide halls, vertical rocky wells and chimneys, underground rivers and lakes. Even despite humans being present in various caves since the very beginning of our species, there is still a lot of unknown and left to explore in the caves. There are still places in the world of caves that wait for someone to explore and be the first person to visit a cave. And with regard to people who are somehow related to caves, interested in caves, I have here three important English language words for you. The caver. Caver is a person who is exploring caves. He is often an adventurer, a courageous explorer, a person who likes to go down into the cave, to stay there, to push the limits of their own endurance, but also of knowledge of human knowledge of the caves. But the caveman is a word that we use to describe a person who lives in a cave, and most often we use this word to describe prehistorical humans, the people who were living in the caves before the houses was invented, essentially, who were seeking shelter in caves, shelter from weather, from animals, from whatever could be a threat in the wide open plains. Cavemen were present in the early history of human race, since even before the Homo sapiens species was fully developed. Even the Neanderthals or earlier hominid species have been using caves as shelter and as a place to live in. And the speleologist, a third cave-related word, is a person who also explores and researches caves in the modern age, but very often speleologist is a scientist or a somehow professional in the caves matter. Speleologists can be geologists who are specialized in cave studies, but also people who are, for example, in rescue teams for caves or any other matter that would require you to be very well trained and very knowledgeable in going into caves, but not necessarily out of pure adventurous motives. Now let's go deeper into the knowledge of the caves, how they are formed, and what different kinds of caves can we find on our planet. Most caves in the world are formed in generally by different processes that alter existing rock massives. So first we have a mountain or a lava field or a large field of deposited rocks, and later with time different physical or chemical processes create caves in those existing rocks. Among those processes are tectonics or landslide processes that are able to create caves. Mechanical erosion that is working over longer time, like suffusion or abrasion, and processes that over a long time are able to carve a cave into a rock. Physical dissolution of rocks in water is also a process that is capable of building caves, and we will hear about it later on. The best examples are salt and ice caves. And finally, chemical erosion, dissolution of rock in purely chemical process like karst, and karst-like processes is also a way of creating caves in existing rocks. And the other broad type of rocks, the less common ones, are the ones that are formed at the same time as the rocks that house those caves. So we have cave formation at the same time as a rock or lava field or something is created. They're most often associated with the surrounding with the volcanic rocks, with lava streams. When lava is flowing over, for example, wetlands, and boiling water creates voids in this lava, and chambers and tunnels can be formed in streams of fresh lava. And this is a case of rocks that form simultaneously with the rock. Reef caves are a special case of caves. Their chambers, tunnels form in coral reefs underwater. These form not exactly in the rock, but in the coral, in the reefs, which sometimes, as we hopefully know, the reefs are conglomerates of living organisms, and they often grow in an uneven rate at different places. So the uneven growth of the corals can lead to formation of chimneys or caves or rocks. These are sometimes shelters for animals, as underwater animals might want to hide in such caves. And for divers, they are very, very attractive space for exploration, since it's a very very attractive underwater landscape to watch, to photograph. Some of those caves, the very old, geologically old reef caves, might have had a phase of terrestrial development when during the glaciation the water level dropped, and those reefs suddenly found themselves above the water surface. Then terrestrial erosion occurred and changed their shape. Then glacial stadium ended, the ocean level rose, and the reefs again ended up underwater. So now let's go through the several kinds of caves I've been mentioning in more detail. Let's start with tectonic caves. These most often form in insoluble rocks, for example, sandstones or other kinds of rocks that are not subject to the chemical and erosion. And they are a result of tectonic processes, the movements of not only the large continental plates, which we often associate with tectonic processes, but also smaller faults or orogeny, wherever an activity of the crust is present, the possibility of formation of tectonic caves exists. In Poland, we find them in outer Carpathian mountains like Beskid Śląski or Beskid Niski, and that's the area where at the outskirts of the Carpathians, which are still fairly active. So the tectonic processes for the last several thousands of years and even more were active enough to provide these tectonic caves. The longest Polish tectonic cave is Wiślanka, Jaskinia Wiślanka Cave. It's over 2 kilometers of length, And another tectonic cave in Poland, Malinowska, is the one that is open to tourists, so that someone might go there and descend into the rocks. Though, as you can see on the image, this is precisely the entrance to the Malinowska cave, and it still is not as simple as one would think. It still requires a fair bit of agility to descend down those uneven steps. Gypsum caves is another kind of caves that are found in Poland, again mostly in southern part of the country. They are formed in the gypsum rocks. Now, gypsum is the rock you might know from building materials, from your houses, from the walls, and that's this rock. The gypsum caves form in these rocks, and thawing processes have a subordinate, so not the major role, but still present in their formation. And these kinds of caves are often take form of dense networks of intersecting narrow fissures, corridors that can be very tall when walked inside. In Poland, they occur in the southeastern margin of the Świętokrzyskie Mountains in the Nida Basin. As seen on this colorful map, looking at the colorful map with yellow and green, the red spots are the gypsum deposits and the areas where the gypsum caves can be found in Poland. And the black and white schema is an outline of one such cave. And let us get used to those schemas, as we will see more of them, of those cave maps, during our webinars. The longest gypsum cave in the world is found in Ukraine. It's called Optimist Cave. It's not only the largest gypsum cave in the world, but also sixth largest cave in the world overall, of all the kinds of caves. And it's total length of corridor in this Optimist Cave of Ukraine is 25,700 meters, so it's 25,700 kilometers. It's really a long cave system, and they reach as deep as 15 meters. Another kind are suffocation and erosion caves, and these are formed in the process of mechanical washing of rock materials. So in a situation where our rocks are for some reason easily either soluble in water or very loosely compacted, the water that comes from the surface in rain or is seeping in from other water sources is able to wash down the material. And the best example are salt caves. In cases where we have deposition of salt, as we all know, salt is easily soluble in water. We can drop our salt into a pot of water, mix it, and it all dissolves. And the same is true in nature. So sometimes the water which permeates the salt deposit is able to wash out some of it and create voids in those rocks due to very long lasting processes of mechanical washing out of rock material. The same might happen in loosely compacted like sands or gravels, which are weakly cemented. But in this case, those caves are much smaller and much more rare than in salts. So, for example, salt mines in Wieliczka in Poland, in southern Poland, are a great example of this kind of rock formation that is a result of water seeping through the rock. And another scheme here, the black and white outline, shows how such cave might look like, and this shape indeed is a different than what we saw previously, more chaotic, more looking indeed like something, a product of flowing water. The next type of caves we will cover are the karst caves, and there's a reason why they got a much bigger title, because these are probably the most famous type of caves, the type of cave that is most commonly associated with the idea of cave. Karst caves form in rocks that are easily dissolved with water that is somehow acidic. At the very beginning, we have the deposits of mostly carbonate rocks. Karst is mostly about carbonate rocks. We have fractures or smaller imperfections in this rock caused by very different processes. And these fractures and imperfections are used by this water as a precursor to formation of rocks. The water accumulates in those fractures or holes, and due to a presence of CO2 in the water, they melt the rock, the carbonate rock that is susceptible to melting in this acidic water. Then the water flows away or seeps deeper into the rock and widens those cracks. And with time, we obviously, as always speaking geological time scales of thousands and millions of years, the process might lead to formation of very large, impressive forms, both overground and underground. The rocks that contain calcium carbonate are subject to the karst processes. Calcium carbonate is a chemical entity with the symbol CaCO3, so it contains calcium, carbon, and oxygen. And it's, as you can see on this chemical equation at the bottom, the rock that's built of CaCO3 is reacting with water and CO2. The CO2 in the rainwater, for example, is very commonly found. It's not because of human-induced global warming. It's been like that. The CO2 was present in water since very long time. And this chemical reaction leads to formation of this salt, the CaHCO3 two times, and this is the dissolved chemical that flows in the water as a solution. Sometimes when the water evaporates, the reaction is reversed, and the CaCO3 might deposit again in its solid form, forming stalactites, stalagmites, and other impressive landforms. The word karst derives from a very particular place in southwestern Slovenia, the Kras plateau on the border between Slovenia and Italy. This is where the most typical form of karst processes are found, and this is where the founder, the first person who described karst geomorphology, was working, the Serbian geographer Jovan Cvitić, in the 19th century. Similar processes that create similar form to karst are called pseudokarst processes. The landforms that look like karst but stem from different processes in different rocks like salts, slash, calcareous sandstones, even ice or quartzites. And the largest area of clearly developed pseudokarst processes is in Venezuela. In South America, in the Sarisariñama National Park, we can see those huge, impressive landforms with 1 kilometer tall table mountains built of quartzites, and within those tall mountains, huge wells connected by cave systems have formed due to pseudokarst processes, as hydrothermal waters with basalt volcanism led to creation of these cave forms. And what's notable for our Polish listeners is that the very first survey of a well in these highlands of these landforms was conducted by a Polish expedition in 1976, led by Mr. Maciej Kuczyński. Now back to the regular karst. On the surface, we can have multiple erosional forms, such as ridges, pots, caverns, cavities, like the ones in the photographs and in the upper right of the slide. They are very clearly oriented to the water flow. In those ridges or pavements, you can see which way the water was flowing when those forms were formed. When the karst rocks are exposed almost completely and the erosional forms show up, they often look like pavement, like a pattern of almost regular rocky blocks with voids between them, with crevices between them. Sometimes they are called alvars, those kinds of landforms. Sometimes they're called pavement rock. And finally, sometimes rocky outcrops with exposed part of caves when the surrounding of a cave would erode away and leave only a part that would be standing out over ground. Underground, the karst processes lead to, again, formation of very many very classical famous cave forms. The water, for example, river water that can enter the cave system through a hole in the ground and drop and end up inside a cave, and then the flow of water with time is creating larger and larger voids, corridors, chambers. We have stalagmites and stalactites that are formed, as I mentioned before, when the dissolved carbonate dissolved in water solidifies again. We have columns formed either from this when the stalagmite and the stalactite connect with time, or due to erosion around the column. There are underground lakes, siphons, lakes, and finally karst springs found in karst formations, as the river that enters the cave system in a higher ground, flows through it and has to find an outlet somewhere. At some point the rock ends and the water suddenly flows out in a completely different place. Sometimes dry caves are also found, even quite often, in places where long time ago these processes were active, but nowadays the water is not flowing through them anymore. Sometimes the karst systems are not only created in vertical systems due to flow of water from above through the rock, but also horizontally in layers of karst that are penetrated by water horizontally. And the most spectacular case of this kind of horizontal cave development is in the USA, in the Mammoth Cave system. It is the longest cave in the world, over 663 kilometers long, but it's a very shallow. It has only depth of 124 meters. The cave system, the entire karst rock formation, is just 200 meters thick. So in terms of cave formations, of rock formations, it's not very much. And this cave system is still active. There are parts of Mammoth Cave system where underground rivers are still flowing, still shaping this underground landscape, while in the older parts of the caves, the water that's seeping through thin cracks or from above ground, when the water that's very saturated with calcium carbonate, with this chemical that forms from dissolution of the rock. When it lands in cavities, in caves, the chemical physical conditions change and an opposite reaction can occur and the carbonate rock appears again. Pseudokarst processes include also ice cave, glacial cave formations, glacier caves. In this case, we are speaking about caves that are formed inside glaciers due to the action of flowing water. The flowing water, mostly meltwater from the surface of the glacier, is much warmer than the glacial ice. So in the ablation season, when the surface snow and sometimes ice of a glacier melts and starts flowing down glacier's water, some of it finds way to the interior of glacier, for example, through crevices or older glacial wells. These are then the warmer water is able then to carve wells and corridors from those starting points in crevices or moulins and penetrate deeper and deeper into the glacier, forming either very steep, almost or sometimes outright vertical wells, then cascades inside the glacier when the water is encountering some problems on its way and has to jump or move in a non-vertical way, and at some point it's even able to carve very tall, large caves inside the glaciers. Now I have to watch my language here on this slide, because ice caves and glacier caves are not the same thing. Ice caves are made of rock. Their ice is accumulating in those caves all the time for the year round. There are no water flowing through those caves. There are no active water courses. And again, the ice cave walls are made of rock, while glacier caves are located inside the glaciers. So that's what I have been talking about for the last minute. The ones that are carved inside the glacier by warmer water is glacier cave, and the building material of the wall is mostly glacial ice, but also any rock material that's carried by the glacier, like sands, gravels, or any kind of debris. These two cross sections show how two caves in Spitsbergen's glaciers look like, and both start with very tall vertical well, chimney, and then either are meandering through the glacier's body towards the bottom, or form very, very tall, big caverns inside the glacier. The glacial caves are very picturesque. The images taken there are very impressive, and the people who enter these places are very courageous, since it's of course it's safe in the time when the water is not flowing anymore. So it mostly in the colder part of the year. During the ablation season, when the water is flowing through those caves, through those glacial caves, it's too dangerous to go there because the water flow might just be too much of a danger. They start on, as I mentioned, on crevices or other kinds of discontinuities on the glacial ice, and might look just like this on the surface as entrances, relatively small entrances to very, very deep wells. Other forms of glacial karst are related to the flowing water again, and are also connected with the debris that surrounds the glacier, the moraines that the glacier might have left in the past. For example, in these two pictures, in the first one, in the photograph, you can see how suddenly a water source is bubbling on the surface of the gravel and sand close to a glacier, and this schema, this drawing, shows us what is happening in this place. The water that flows through those glacial caves is penetrating the glacier much into the ablation zone, into the terminal part of the glacier, and the spring, a source of water, is formed already beneath the debris cover on top of the ice body. So the water needs to move through those gravel sands to escape the channel system. Again, two more pictures from caves, from glacial caves. Some of them, as you see, are big enough for researchers to set up camp, to build tents and stay there for more time than just a few hours. Another one is a chamber above the outflow of waters from underneath the glacier. And if you can see the massive ice crystals there, they are the result of recrystallization of the glacial ice, and their exploration, the people who go into glacial caves very often do that for scientific reasons, to learn about the processes that occur on the very bottom of glacier, in this area between the ice and the rock, or even inside the glacier, to watch the various aspects of the glacier, such as its draining system, the ways water flows, or how the ice transforms inside those caves. Now let's speak a bit about humans in the caves. So, as I've mentioned in the very beginning, humans have been interested in caves since the time immemorial, since the very beginning of our species and also the earlier humanoid species. At the very beginning, it was an accidental refuge, a place to hide from the dangers. Later, caves became the temporary residence space for hominids. And the great majority of remains of prehistorical humans that we have found and can use for archaeological or biological research come from discoveries that were made in caves. So in the last few tens, thousands of years, caves became spots for development of artistic abilities of humans. They became places of worship. That's where the very, very early human society was developing, and suddenly humans invented houses, started to build dwellings for themselves, and the caves gradually lost their importance as a spot for residence and became first again the temporary refuge for in case of dangers or for people who are running away from the law or from society, or they became storehouses because of their stable climate and temperature. Then nowadays, at least in the developed world, the caves are mostly objects of scientific research and tourist exploration and sport activities. They don't hold that much importance for us as a society, although they still bring a lot of archaeological knowledge and information. Now, and one example of a cave that brought very interesting information about history of human species is the Denisova Cave. It's a fairly small and apparently insignificant cave in Russia, in the region of Altai Krai, and it's where very sensational, very interesting discoveries were made about human information. The archaeologists found 20 layers, 20 archaeological layers of human remains, human-made tools in the sediments found in the cave, the oldest of which were dated to 300,000 years ago. And the researchers, the geneticists, found a new species, new species of human. They call it Denisova caveman because it's the first time this remains of this species have been found. And all those findings suggest that the Denisovan humans, the Neanderthals and Homo sapiens, that's modern human species, have been using this cave for different purposes, most probably to live in it as a dwelling for many thousands of years, sometimes maybe even together. So it's possible, thanks to those findings, to build a hypothesis that the different species of humans might have even met with the others. And now I will show you a short film from National Geographic that is about the cave paintings. The cave paintings are very, very interesting topic. Again, something very important for archaeology and for studies of early human societies. The movie will be in English, but obviously it shouldn't be a problem for us. Wait a minute, I heard you don't hear what's being told. Is it better now? So the sound is exactly the same as what's written. I can't see a way to quickly fix this. Okay, good. I believe you can see again the presentation. Oh, you can see the film. Even though I have... Now we have... Yes, good. So that was the last part of the last slides of the webinar. The whole EDU-ARCTIC 2 module about caves and humans comes with an exercise sheet that was available at the website, where some activities can be done, some of them related to the presentation, and some of them more farther away from the knowledge and topic of what I've been talking about, but still very closely related to caves and their life.
Watch other recordings from webinars on our YouTube channel, youtube.com/EDU-ARCTIC. EDU-ARCTIC 2. From polar research to scientific passion, innovative nature education in Poland and Norway receives a grant of 240,000 euros received from Iceland, Liechtenstein and Norway under EEA funds.